702. The Naked Scientist.
We go to the Naked Scientist. That's Dr. Chris Smith now. It's 20 minutes to 3 o'clock. Hello, Chris.
Hello. How are you doing?
Very good, very good. And we are just contending with a little slightly chilly weather, but, winter's on its way out and we can't wait for spring.
You're getting your comeuppance, you see, because you were gloating to me last week about how your weather's getting better as ours is on the slide. Ours has stayed reassuringly rubbish ever since. We've had about a month's rain in one day. People are lighting their log burners because even though it's still August, ostensibly, it now feels like we're into winter. It's just amazing, isn't it? 2 weeks ago, it was 34.5 degrees and no one could move. And now it's sort of barely above the temperature you'd expect in autumn. But there we are. Can't complain.
Miserable.
Miserable. Well, serves you right anyway.
It's your doing. Your heart has been holding on to it since last week, and look at us now. So let's get to the calls. We're taking your calls this afternoon with Dr. Chris Smith, the Naked Scientist. We go to Costa in Norwood. Afternoon, Costa.
Hi. If I'm not mistaken, going back to the beginning of COVID, the temperature at which the COVID virus has difficulty in coping with is above 26, 27 degrees centigrade. Is that correct?
Well, remember that the coronavirus that we're worrying about at the moment is a human infection, and therefore it's going to grow best at body temperature. Human body temperature is about 37 degrees. So it's growing best at that temperature, but surviving, all viruses survive best at lower temperatures up to a point. So therefore, if you were to put the virus in a fridge, then it would last longer than if it's in the open air.
Okay, well, the question was basically because, I remember everybody saying that it survives up till below, it'll be up to middle 20s, but it's difficult then for me to understand how it can survive in a human body at 36 degrees.
All viruses are quite fragile, really. There are some that are a bit more resilient and robust. Our friend the norovirus that causes winter vomiting disease is pretty robust. But most viruses, like coronaviruses and influenza viruses, they're actually quite fragile. And when they're in the body, they've got ideal temperatures and conditions to keep the virus particle viable. And when they leave the body, they usually do so in the form of droplets from the airways. So when I'm breathing, when I'm talking to you, actually, I'm spraying out a fine mist of droplets from my airways. If I have a virus, pretty much any virus that grows in my airways, I'm going to spray out with those droplets pre-packaged virus in the droplets. But as those droplets evaporate and they lose water, eventually you end up with just naked viruses there, and they can dry out and they're quite fragile and they'll fall apart, which is why the virus only has a certain lifetime on a surface before it effectively becomes dysfunctional and doesn't work anymore. So basically, the longer it's outside the body, the less time it has to live, unless you put it under very low temperatures and store it. And we can store viruses in the freezer in the lab indefinitely if we keep the temperature really low, as far as we know.
Interesting.
What was your other question?
Chris, I've read about you and listened to you for years and years, and it amazes me the amount of knowledge you have. So given that you have that amount of knowledge and you retain it for so many years, please answer this. What do you think about religion, or your personal views, if I may ask that, on religion?
I don't see any tension between religion and science in many respects, because science does what science does and religion does what religion does. The two things are not comparable. They're like apples and oranges. They're two totally different disciplines. They're two totally different belief systems and two totally different ways of approaching and analysing the world. And actually, religion is not incompatible with science. If you were God and you made the Earth, then you would obviously put in place patterns and rules for the biology on Earth to follow, which is what effectively Darwin has explained with Darwin's theory of evolution. That's not at all at odds with anything that's in the Bible. And also, if you wind the clock back, you ask about the Big Bang, to the beginning of the universe. The universe is about 13.8 billion years old. We actually know there was a beginning, and we've got various strands of evidence that prove there was a Big Bang at which the universe popped into existence. Now, we don't know what was there before the Big Bang, and we don't know why the Big Bang happened, but we do know that at that time, our universe that we're in was born. Now, that could be considered a moment of creation. And in fact, one of the early cosmologists, Lemaitre, he was a Belgian priest, and he was very comfortable with the idea of a Big Bang and the origin of the universe having one point in time, because it fitted very nicely with a moment of creation in the Bible. Now, we might have got the timing a bit wrong, but who knows? So I don't have any kind of problem with religion and science. The only issue I do have is when people take one into the realms of the other, and they try and apply science to religion and religion to science. They are two totally different things, and one is not at odds with the other, but we should not mix science lessons up with RE lessons in school and vice versa.
Right. Costa, thank you for those two great questions.
Thank you very much.
Thank you. That's Costa in Norwood. And next we go to Ruwaida. Ruwaida, you're on in Deckers Park. Hi.
Hi, good afternoon. My question to Chris is, you find all these colorants and preservatives in our sauces. How bad is this for our health? Is this perhaps a contributing factor to the different cancers we find?
Hello, Ruwaida. There are some examples of certain food additives and chemicals which have subsequently been shown to be bad for you. Things like Sudan red and stuff like that, various dyes and other pigments, which we used to think they were harmless. After enough time of gathering enough data, we begin to see an association between exposure to them and people becoming unwell. Those things, though, are few and far between, and the things that are added routinely to food, additives and so on, are in fact doing a good job of keeping food safer. Many of these additives are things like vitamin C. Vitamin C is a food additive. It's not coloured, admittedly. It's a colourless molecule, but it's adding additional safety to food because it's an antioxidant. So if food doesn't oxidise, then you're not turning other chemicals in the food that could potentially become nasties into nasties because you slow down the rate at which that happens with some of these additives. So additives aren't all bad. There have been some in the past with a checkered history, but not all. And the vast majority of them are tried and tested, they are considered safe, and there isn't evidence linking them to behavioural problems or other health issues. That said, we're always monitoring, always watching, and people are looking for these kind of associations, and if they see one, they make sure it's not chance or some spurious association, and if there is any evidence that bad things are going on, they take steps to make sure that that's stopped immediately.
There you go, Ruwaida.
Thank you.
Comforted?
Thanks so much.
Thank you. Ruwaida in Deckers Park. So we're taking your calls this afternoon for Dr. Chris Smith, our naked scientist. And this is where you get to really pose your science curiosities with him. And Joe has done exactly that. Your calls on 011-883-0702 right now. Joe, hello.
Hello, Azania. Azania, I'd like to ask him about asymptomatic patients with COVID. Are they infectious? Because as I understand it, and as the World Health Organization has explained, it is the pre-symptomatic patients who are infectious. Otherwise, there's no carrier state with the COVID virus. What is the situation, Dr. Smith?
Hello, Joe. The answer is that anybody can get infectious with COVID. Anybody can catch the virus that causes COVID. And you're most infectious when you're most symptomatic, we think. But you're also infectious before you get any symptoms, and you remain infectious for a period of time after the symptoms begin. So what about the asymptomatic people? Well, we also think they're infectious. We think, in fact, they make up a very significant proportion of cases. They might make up half of all the cases of coronavirus that we've seen. And what we don't know at the moment is the extent to which they are infectious. But we think, given the success with which the virus has spread around the world, how many people it's got to, that the individuals who are asymptomatic are also infectious. And so that's part of the headache that's come with controlling coronavirus, because a lot of the testing, a lot of the controls that we've put in place, we assumed it would be very similar to things like the flu, where when people have symptoms, they've got the flu, they've probably got infectious, they're probably shedding virus, we need to isolate them. With coronavirus, if you go around saying, have you got symptoms, and then you discover that half of the patients have no symptoms, you realise you're missing a lot of potential infectious sources. And we think that's why we've had so many cases spread the way that the virus has, and that's why it's proved difficult to control. So that's where the testing and tracing comes in. When you pick up a case of coronavirus, going to the contacts, regardless of whether they have symptoms or not, and testing them can be a very powerful way to arrest the spread of the virus, because it does get to the heart of this asymptomatic phase. And then you'll ask me, why do some people have no symptoms and another person catches it and can die? And we just do not understand why some people have this dramatic reaction to coronavirus, but we are trying to find out.
Joe, there you go.
Dr. Smith has done work on the late manifestations of the coronavirus in a small percentage of proportion where patients develop antibodies against body components. Which are the components to which the coronavirus develops antibodies to? Or rather the body develops antibodies to, not the coronavirus.
There are a range of different targets on the virus, Joe. The ones that we're looking for a number of them with the tests we make, but the structure that makes up the virus, there's the spike protein on the outside, there are other proteins that make up the coat of the virus, and then there are things inside the virus that it uses as its machinery to make more virus particles. All of those things are displayed to the immune system when you are infected, and all of those things are so-called immunogenic. You can make an immune response to them, and a person who's naturally infected with the virus probably does. Some of those things, though, are more immunogenic. They make more of an immune response than others. So although people will make a response against any part of the virus, potentially, you tend to see certain parts coming up more in the test that we're doing. And the key to making a good antibody test is actually to go and find a part of the virus that as many people as possible respond to and make your test base itself on that. But the bottom line is anything's up for grabs. Pretty much any part of the virus will drive an immune response if your immune system can see it.
That's Joe and Kilani as we try to understand this virus a little bit more. I don't know, where is this pandemic going, Chris? I'm sure there are different models, or some pandemics have tapered out in different ways over the years. But with this one, it just seems like there's no end in sight. We are seeing a decrease in numbers of infections, right? So there's a slowing down. Our R0 has become smaller. Or let me say the numbers that are being reported, let's be honest, because maybe there's a discrepancy between the real rates of infection and the numbers that we see. But ultimately, we've seen certain conditions come and go. You'd have a flare-up of Ebola, for instance, and then with awareness and management and so on, it kind of comes to an end, as we saw recently. But with COVID, is this just going to be ongoing?
We don't know. At the moment, it's got to tens of millions of people in terms of cases. The death toll around the world, probably close to about 1 million people now. But actually, the flu, in a bad flu year, claims 1 million people, and the flu does this every year. So we have to keep a sense of proportion about this. It's a really difficult virus to control. We currently have no vaccine. We currently have 8 billion people on Earth whom we have to get a vaccine into if we're going to stop this thing. So the answer to your question is that it's going to be a long while before we're in a position to completely control this. The reason that the levels have gone right down is because people are being extremely cautious. There's been lockdowns of many of the world's populations, and this has obviously cut off the number of contacts the virus was exploiting to spread from one person to the next. But that doesn't mean that it won't come back, because the world population remains vulnerable. We're still infectable, and there are a large number of us that haven't had it, therefore we're not immune. And the other fly in the ointment now is that a number of reports have now been published of people who caught the virus, cleared the virus, and have now caught it again. There was a case report from Hong Kong of a gentleman who caught it back in March, April, was in hospital, sufficiently unwell to be in hospital with it, recovered, tested negative, and then having travelled, he was going through Spain, went through London, and then returned to Hong Kong. In the last few weeks has tested positive for the virus again, but you can prove this is reinfection because the virus he's now got has a different genetic makeup to the one that he caught originally, proving he's caught another strain of the same virus, proving that the immune response he made to the first infection wasn't sufficient to protect him as little as 3 months later. And now the US has published a similar case report. So this is going to be another challenge to us, that where previously we thought people who've had it, they're probably going to have at least some semblance of immunity. That is not a given, and it appears that at least in a proportion of people, the immunity is not that long-lived, and they may well be vulnerable and catch it again.
Yeah. Let's go to, is it Tiatu in Pretoria? Hello.
Hi, I've got 2 questions quickly. One, given the position of the Earth, at what point does one say you are out in space? And secondly, we lose sensation when we are sleeping.
All right. Chris?
Okay, first one, where do we consider space begins? Well, actually, there's no absolute marker for this, but there is a concept called the Kerman line, which is 100 kilometres above the Earth. And it is at that point that we regard the Earth has stopped and space has begun. But the Earth's atmosphere extends for a long way out into space in terms of very thin wisps and vestiges of our atmosphere. So the International Space Station, which is going round at 400 kilometres altitude, is still feeling a bit of drag from the Earth's atmosphere and periodically needs to be speeded up in order to make sure it doesn't slow down enough to make it fall out of the sky. So there's no absolute Earth stops, space starts, but 100 kilometres Kerman line is regarded as the main point at which we go from the Earth's atmosphere and into what we call space proper. The other question about paralysis and sensation when we sleep. When we go to sleep, we definitely deactivate our systems that enable us to move. And this is done with good intention, because if you were to act out your dreams, you could harm yourself. So when you go to sleep, there is a region in your brain stem. It's in the subcerulear region, which is the bit of the nervous system connecting the brain at the top of your head to your spinal cord. And as the messages come down from your brain going down towards the motor nerves in your spinal cord, when you go to sleep, this region engages and turns off that supply of information so that you don't end up acting out your dreams. You do, however, retain sensation, because if you pinch someone, kick someone, if they were to lay on the same part of their body for too long, they could get pressure sores, and they need to be able to respond to things going on around them. So although we deactivate the motor system, we don't deactivate the sensory system when we're asleep in bed at night.
Fantastic. Chris, thank you very much. We'll see you again next Monday.
All right. Thanks, Azza. See you soon. Bye, everybody.
Yep. That's Dr. Chris Smith, our naked scientist.